Welcome, everyone. This is actually the first time we're presenting a Java 8 webinar after Java 8 GA launch. So I suppose everybody noticed. This is Spring Framework on Java 8 GA now. And in this particular session, I'd like to do of course, a Spring Framework perspective, but a strong Java 8 focus in terms of how natural the language features and the API, VM, library features in Java 8, how natural they really fit with the Spring programming model. So this is a very pragmatic session in the sense that we are going to look at a few examples, just reference examples basically, that show how immediate some of the Java 8 features can be adopted and how immediate the impact of those features can be onto your Spring-based code bases, Spring-based application code bases. We will be covering a little bit of the general Spring Framework 4 feature set for a start. So I'll give you a rather quick overview, just to remind you that it's not all about Java 8. The Spring Framework 4 release, 4.0 release, the 4.0 line has many things to offer. Among those, of course, it's Java 8 focus. But for the remainder of this session today, we will be focusing on Java 8 features in combination with the Spring programming model exclusively. All right, to warm up, let's have a quick look at typical Spring-based code examples. This is basically what we're starting from when we're talking about a modern-day Spring Framework 4 application. It's the annotation-based component model in Spring. It's basically what we're seeing here: stereotype annotations, injection annotations, and declarative service annotations, such as transactional. That's really the sort of style that's basically our reference point for many things that we do and for many of the improvements in the Spring Framework 4 generation. Let's just keep this as our context, basically. An important addition to the general component model in Spring are configuration classes. So a reminder, configuration classes here are a really powerful element of the programming and configuration model in Spring. You can do many things with configuration classes. And this slide here actually indicates quite a few things. So just pointing at a few things here, add configuration above is a stereotype. It says this is a configuration class. It contains add bean methods. It will actually declare beans to the container on startup. Add profile is a condition, a special kind of condition. In the Spring Framework 3 generation, it was the only condition we actually had. Basically says this part of the configuration is only to be activated if the profile standalone has been marked as active on startup. As another kind of just example for what kinds of annotations we find here, let's look at enable transaction management quickly. And enable annotation, basically the sort of equivalent of XML namespaces in the annotation world. Our translation of powerful but simple container configuration features in the add configuration model here. So that's, of course, not all you can do here. You can do much, much more with configuration classes, but that's very typical. The stereotype, then kind of conditions like add profile here. A few add enable annotations maybe. And, of course, the actual factory methods, add bean methods down there, like the myBucketBean service method here. Declares a Spring Bean, so there's actually a Spring Bean definition derived from it at runtime. Every time the container needs a fresh instance of that class, it basically calls that factory methods. So it's kind of a combination of a factory method and a bean declaration, bean definition. The add scope annotation found here actually changes the default scope from singleton to session. So add scope is a typical example for a metadata annotation, a piece of metadata that you can add to your component classes or to your add bean methods here. changing default semantics that the container applies to the instance that you're to the bean that you're defining here. Add primary is a kind of simple qualifier. Like we have a few of those. We have add lazy, add primary, a few of those little additional flag-like annotations. But add primary is a bit special in that it's actually a sort of qualifier. So it influences the auto-varying process. So auto-varying, a pretty important part. You use add auto-var, you use add inject. The container's job is to find matching instances or the most appropriate matching instance. If there are several matches by type, that's when qualification comes into the picture. You can either use qualifiers, so qualify by the presence of a specific qualifying notation, or you can use a primary here. The primary basically says if there is any other book admin service implementation, any other bean implementing book admin service at runtime in the container, if in doubt, choose me. I am the primary candidate. So those kinds of things you can express using annotations in the modern day Spring component model, and particularly interesting and probably the most powerful and one of the most unique features Spring is offering here in the annotation-based space. That's what we've been looking at here. That's configuration process. All right. So let's move on. In the Spring Framework 4 generation, we have several important refinements. So for a start, for the moment, ignoring Java 8 just for a little bit more, we actually have several container level features. In Spring Framework 4, there are quite a few enablers at the container level, and there's quite a bit of additional ground that we're covering. So I'd like to give you a quick overview of what that really means. There has been a bit of a big picture motivation behind this. We have a stronger focus on non-traditional deployment environments these days. Deployment of embedded web service, for example, deployment of embedded data stores, integrating with non-traditional data stores, non-traditional messaging systems, and of course, modern day web architectures. That's basically everything you can possibly do to create the best possible web user experience and efficient web-based communication these days. So we're really trying to shift our focus to extend our reach really into new ground here, into ground that's not particularly first class with most of basically last year's frameworks. So Spring Framework 4 is very geared towards architectures that we will be building over the next few years, as opposed to the architectures that we have been building for the past 10 years. Anyway, that's a bit of a guideline in the background, but maybe more concretely, we have a new baseline of basically minimum dependencies that we're supporting. Shouldn't really come as a surprise and shouldn't scare you off by any means. We basically erased our minimum JDK dependency to JDK 6. It's actually a bit more specifically defined, as you can see here. It's JDK 6 update 18 or later in terms of the bug fix level and the API level that's included in the JDK. That's about 4 years back, so we're still rather generous in supporting existing deployment environments. We have an analogous raise in the baseline for many of the other specifications that we integrate with. They are basically all at Java E6 level now. So we're Server 3.0 focused. We require JPA 2.0 or higher. So there have been a few of those where the minimum is just basically on a late 2009, early 2010 bar now. There is actually a special note at this point, since it's a common question. We do remain Servlet 2.5 compatible at runtime. So it's strongly Server 3.0 focused. You'll notice that with the mocks, for example, that we're shipping the Servlet API mocks. However, at runtime, there's a careful balance where we're not actually relying on Server 3.0 API unless you decide to rely on it. So you're a little bit limited in what you can do, of course, There are no web application initializer classes for you if you're on Servlet 2.5. But if you have an existing Spring-based application that works fine on Servlet 2.5, it will also work fine with Spring Framework 4 on Servlet 2.5. So that's primarily for application server environments where it's not that straightforward to upgrade the servlet level. WebSocket 7, for example, previous generation of WebLogic, but also Google App Engine. So there are quite a few that are still at Servlet 2.5. All right, so that's basically our new baseline. Let's move on to the container features. Just a few quick examples, and notice the subtle differences here. In what you're seeing here doesn't look particularly new, right? It's a component class, it has a constructor marked with that auto-wired. In a different class, you would find the add-bean method below, probably in some configuration classes, as we've been seeing before. There's an add-bean method that builds this repository instance, defines this repository bean. And obviously, the container is in charge of matching those. So finding a good match for the injection point, which means it looks at the constructor. It says the constructor wants this repository of a specific type, and it tries to find the best possible match among the candidate beans in the container that have been registered with the container. The special part here, the Spring Framework 4 specific part, is the use of generic types. We are declaring our dependency as my repository of account. My repository would be an example for any kind of generically typed interface. You can define those yourself. There are several examples out there of predefined generic interfaces, of course. Even our Spring Data sister project uses them quite extensively. So any such interface, whether predefined or customly defined by yourself, is now being matched based on the full generic type declaration. In the Spring 3 generation, we would only have looked at the my repository part here. We would have said, like, let's find the bean that's assignable to the my repository type. And we basically ignored what it's been declared for in its generic type structure. Now we are going to look for a specific match for my repository of account. If there are several my repository beans in the container, maybe one declared for account, one declared for order, one declared for country, we're going to ignore the ones that aren't matching based on the generic type. We're actually going to pick among those candidates, we're going to pick the very specific my repository account one, if possible, right? If the target beans actually are declared that specifically. This is a quite complex algorithm in the details, so it's a significant change in the container, at the very heart of the container. However, it's a great enabler for custom generic type structures. Instead of having to add qualifiers, you can actually rely on the generic type information itself as a kind of qualification mechanism. As long as the type information, the generic type information, is expressive enough, there's no need to add qualifiers. We're going to find a proper candidate based on that generic type structure. So the problem could have been solved before through qualifiers, through additional metadata where you're repeating yourself to some degree. Now you can basically forget about additional metadata as long as the type information is expressive enough. That's the generics-based injection matching algorithm in Spring 4 for a start. Another subtle refinement in Spring 4, subtle but important and enabling refinement, that's the use of attributes on composable annotations. What we're seeing here are custom annotations that you would define yourself. You would include them in your code base. You would start using them on your components, and maybe for the purposes of alignment across the code base, you would define some custom annotations. Maybe it's just as a convenience, as a kind of shortcut, instead of having to repeat a longer winded combination of annotations, you would maybe define a few custom ones. That was possible in Spring for quite a few years now, ever since the Spring Framework 3 generation. What's new here in Spring 4 is the use of attributes. This custom scoping annotation above here, my session scoped, has a proxy mode attribute. And that attribute, just through its presence, just through it being declared here, is being matched against the same named attribute on the @scope annotation. So our custom scoping annotation here is able to override an attribute on the meta annotation that it is being declared with. @scope is Spring's standard scoping annotation. That's why we basically allow you to do things like you can see here now. A scoping annotation that says my session scoped hard codes the session part. So it basically says I am a session scoping annotation. However, I leave the choice of proxy mode, of scope proxy mode, to my user. Whoever declares my session scoped annotation is being bound to the scope name session, but is still free to choose a proxy mode. So you can basically express a specific combination of basically freedom or flexible use of freedom to do a few custom things, but limitations in other respects. Custom annotations, composable annotations in that custom form here are being used as a measure for guidance, as a measure for basically team commonality, where everybody would be using the very same annotations. There are many reasons why you would use custom annotations, in particular in larger code bases. With the use of attributes here, we basically just allow you to be even more specific and even more fine-tuned in what you'd like to express in the guidance that you'd like to deliver. Towards the guidance point, have a look at the my transactional annotation below, a custom transaction annotation. Meta annotated with @transactional, that's Spring's standard transaction annotation, has a hard-coded rollback rule in there, just an arbitrary example. In the specific Spring 4 oriented incarnation here, it also has an attribute. It declares a read-only attribute. And notice the non-availability of a default here. So this annotation declaration basically declares a mandatory attribute. It says like, here's the read-only attribute. Every time this annotation is being used, this read-only value has to be specified through @myTransactional read-only equals true or false. That goes in the direction of guidance again, because this read-only attribute overrides the same named attribute on @transactional. @transactional has a read-only flag, it's false by default. This myTransactional annotation also has a read-only flag, but it's not false by default. It basically asks its user to think about the read-only status very explicitly. It's not simply defaulting to false. It says like, think about it. Is the status true or false? You need to be explicit in specifying it. So that's just two examples of what you can do with composable annotation and attribute overriding in particular. It's completely up to you, or maybe up to third-party projects as well, predefining some of those. It's fundamentally an enabler to allow you to express things that you couldn't quite express before in a custom annotation arrangement. There are quite a few further container refinements, and to speed it up a little here, we're just going to point you there. We have a generalized model for conditions. So if you remember the @profile annotation from before, if you have been using it in practice, @profile is now just a special incarnation of a condition, quite literally. The profile implementation is literally a profile condition now, and is expressed through @conditional, a more general, more flexible version of it, a more dynamic version of conditions, where a condition context comes in and you can programmatically evaluate what kind of decision you will be making on startup here. And the decision doesn't have to be as static as like checking against profile properties of any kind. It can be very flexible. You can react to runtime state. You can react to other bean definitions being present or non-present. There are quite a few things you can do in conditions. And this is a key enabler for our Spring Boot initiative. for this more recent part of the Spring portfolio. It's actually just about to go generally available. So Spring Boot 1.0 GA is just a few days away. In Spring Boot, they are making heavy use of conditions. So basically the existence of the Spring Boot project is almost enabled almost exclusively enabled by this condition model in Spring. It's the central enabler that Boot requires that allows basically Boot to do its thing. So Boot is great. I mean, have a look at it. It's a completely different experience in getting started or in even deploying Spring-based applications. At Conditional, the condition model is the Spring Framework full feature that enables it all. There's quite a bit more. On injection points, you can declare at lazy next to at autowired or at inject now, requesting an injection point specific lazy init proxy. So instead of putting the lazy marker on the target bean definition where it's always lazy, you can basically turn it around, look at the injection point about basically the client side and say like, this various bean here requires a reference to that other bean, but for this specific bean, it may be lazy. You could express that using a provider before, so there was a way to do it. At Inject has this provider interface, and you lazily call get on it every time you require access to an instance. At lazy is a proxy-based version of it, basically. So that's a nice addition to the heart of the component model. Related to that, for injection points, you can request ordered injection of arrays and lists now. Arrays and lists worked before, but you didn't get them in any well-defined order. Now you can actually express that order among beans, and you get the beans pre-sorted when they arrive at the injection point. On a slightly not so cool container note, moving to the AOP framework, we also have a central change or a central new feature, and that's the use of the Opgenesis library for the creation of CGD proxies. Now you may wonder why Opgenesis, what's that all? It doesn't matter. It's repackaged in Spring. You just get it with Spring Framework 4, so you don't have to worry about a dependency here. The key here is we're creating target class proxy instances without calling a constructor now. Opgenesis basically is an enabler to allow us to create instances without a constructor invocation. Because if you think about it, with a target class proxy scenario, the constructor invocation only really makes sense for the target bean instance. That's what you're constructing. That's where the state is being held. That's where the invocations are actually handled at runtime, right? The proxy is literally that. It's just the proxy. It forwards calls basically to interceptors and to the target instance eventually. The proxy itself doesn't have to be constructed in the sense of executing the code in a constructor. It's actually even semantically wrong to execute the code in a constructor, you could argue. So just a little bit of explanation here for why we're doing this. The correct thing to do for a proxy is to basically not have any side effects through the creation of a proxy instance. That's why we're using Opgenesis here. As a nice little additional effect, you're actually completely free to declare any constructors on beans now, even if you create target class proxies for them. So maybe you ran into that restriction before. The basically came as a natural limitation with CGD. CGD had to construct the proxy instance using the default constructor before, so you had to declare a default constructor. That rule doesn't apply anymore. You don't have to have a default constructor. You can have any constructors now, which is particularly interesting for constructor-based injection. So no need to use interface proxies anymore just because you love constructor injection. It works in almost all scenarios with target class proxies as well now. All right, so that's a favorite little change of mine as well. Let's wrap up the feature overview. It's not all in the core container. A few additional things we've been doing. Lots of work, lots of great work in the messaging space. We have a completely new messaging module, which is Common Ground, that has been extracted from the Spring Integration project in particular, is being used by Spring Integration 4. So it's in a more common place now as a kind of common interaction point in the common API definition module. We are also using it in our own WebSocket support, and specifically in the Stomp on WebSocket support, in our support for the Stomp messaging protocol, typically used on top of a WebSocket communication channel. This is quite new ground from the Spring Framework perspective, but stylistically, it's not going to surprise you, I believe. It's if you look at Stomp endpoints and if you dive into this, there's plenty to discover there. And you're familiar with Spring MVC and its handler method model, you should find familiar ground there, familiar rules, familiar conventions. However, this is a quite deep topic. If you're interested in that part, I definitely recommend to check out the many things that we've been publishing already. Rossen's blog post series. There are a few recordings of Rossen's talks about WebSockets already. Definitely check those out. There's plenty to discover. And Spring Framework 4 makes many of those things first-class features now. Previously, you had to find custom solutions for any such architectures, basically. And now we have first-class elements allowing you to build Spring-based application architectures with those things in mind right from the beginning. All right. So that's really a kind of focus topic in its own right. Certainly as much ground being covered here as the Java 8 topic implies. So a great second major theme in the Spring Framework 4 generation next to Java 8. All right, and it's not just Java 8, Java SE 8. It's also about a little bit of Java EE. The Java Enterprise Edition 7, as released last year in terms of the specifications, has quite a bit of stuff that we can immediately adopt in Spring Framework itself. So if you happen to have a JMS 2.0 provider or a JPA 2.1 persistence provider, such as Hibernate 4.3, for example, Spring Framework 4 auto-detects them and automatically uses them. So Spring, in its fourth generation here, of course, supports the Java EE 6 Plus level. So it does support JPA 2.0. It does support JMS 1.1. But it automatically adapts to this more recent generation of APIs if encountered at runtime. So if you're using Hibernate 4.3 or a JMS 2.0 broker, it's just going to work. The bean validation 1.1 part is also important because Hibernate Validator 5 in its current generation 5 is a bean validation 1.1 provider for the first time explicitly supported here in Spring Framework 4. And as a kind of favorite pet of mine, we have the JSR-310 finally making it into Java EE proper. This is an old JSR. It's been promised for so many years. It fundamentally defines rules for exposing user-defined thread pools from an application server to an application, and also to an application framework, of course. So if you're familiar with some of Spring's functionality that requires thread pools, you might be aware that we have a task executor abstraction, a task scheduler abstraction. We have support for embedded java.util.concurrent thread pools next to common J-based thread pools that are typically coming from WebSphere or WebLogic. This is basically going right into that ground. JSR-310 concurrency is a kind of extension of java.util.concurrent with rules how it's to be exposed from an application server. So with JNDI binding rules and so forth. From a Spring application perspective, we can look up the appropriate executive service references here from JNDI and use them with almost anything in Spring that can make use of a thread pool. So with Spring's GMS listener support, Spring's cron trigger support, everything that requires asynchronous execution. So that's, even if it's not commonly used in application server products yet, because they're not on necessarily at the Java E7 level yet, it can already be tried. It's supported in Glassfish 4 and Wildfly 8 at least. And as it's more commonly found in practice for deployment environments in practice, this is going to be an interesting piece, an important piece in the puzzle, where we basically, from an application perspective, from Spring's perspective as well, have now, where we have a model that gives us first-class access to custom thread pools and custom thread management in an application server environment. That's a really important enabler, in particular for the kinds of application architectures that we start seeing these days, where some kind of asynchronous processing is almost bound to be part of the architecture. It's not all left to the traditional application server ways of threading. Some custom asynchronous processing is something is going to be very common in the next few years, I'm sure. All right. So much for the initial part here, the initial half of the talk, where we are basically find ourselves on the Spring Framework 4 generation with quite a bit of stuff in there. Many of those things work great on Java 8, but we actually haven't talked about the Java 8 specific features yet. So what do we actually mean when we say Spring Framework 4 has first-class support for Java 8? We identified quite a few specific features. That's not a priority list or anything, right? It's basically those 5 features here are the ones with the strongest connection to the Spring programming model. There's some other great stuff in Java 8, so definitely make sure to check out, for example, the collection stream APIs and a few other things in Java 8. However, those things are basically orthogonal to what Spring is doing. So the ones with a direct impact on Spring-based code are the ones here. Lambda expressions, method references as a kind of sibling of Lambda expressions, JSR-310 Date and Time, something I find particularly important to have as common ground. The notion of repeatable annotations, which is a little bit subtle, but you'll see what we can do with it. And parameter name discovery is a first-class compiler feature now, and first-class runtime reflection feature. So those are all Java 8 features that I'm going to explain to you basically within the context of a Spring-based code, of a Spring-based application. All of those make immediate sense and are just great to use in combination with typical Spring ways of doing things. That's, of course, first-class Java 8 features. Most of those require Java 8 bytecode, require a compilation with source 1.8, so they're really Java 8 as it is features. There's a kind of softer way of running on JDK 8 as well, and I'd quickly like to mention here, of course, that Spring-based applications can also work great on Java 8, on a Java 8 runtime environment on JDK 8. Even if they are being built with Target 1.6 or Target 1.7. So if you have existing Spring-based applications, or you have a large code base and you're not really willing to migrate it to the Java 8 source level yet, that's a scenario that we are explicitly focusing on to give you the best possible Java 8-based runtime experience for Java 6 or 7-based applications. Even those may be reasons, even those scenarios. There may be a reason why you're upgrading. At the JDK 8 level, we have plenty of new stuff to find for our runtime environments. Basically, the removal of the permgen, different kinds of memory management models, the runtime impact of what we're getting with the JDK 8 generation here is very significant as well. It's not just about language features. It's also about JDK 8 as kind of a modern day runtime behavior that we're getting there. All right. But for the remainder of the session here, let's focus on the source and API level features, the development experience basically with Spring 4 and Java 8 in combination. The whole idea of Lambdas in Java 8 is actually quite nicely defined. It's a convention. So this notion of Lambda expressions, which is basically a Java 8's way of expressing concise closures, this entire model is a compiler feature and works with a convention. You can take a Lambda expression and basically have it compiled against a target signature. For example, you pass it in as an argument to a method call. The compiler checks the target method parameter types and does the best it can with your Lambda expression in adapting it to the target type that you're passing it into. You're going to see an example in just a minute. This whole idea that it's convention-based is really, really nice because it means that existing interfaces, such as runnable and callable mentioned here, but plenty of interfaces in Spring, interfaces with just one method in them, basically. Typical one method callback interfaces. Those are really immediate candidates for Lambda expressions, just by convention, by design, basically, by their design model. There's no need to have any kind of special markers or anything else on them, which in particular allows us to deliver a framework to you that works on JDK 6, 7, and 8 with the very same classes, the very same interfaces, in the very same jars. But on Java 8, due to a design convention, you can immediately use Lambda expressions against them. It's actually really great, in particular for this transition period that we're entering now, where so many things are on JDK 6 and 7 level. Java 8 isn't going to be ubiquitous before 2016, 2017. In this transitionary period, it's so important to keep using existing APIs, existing conventions, existing frameworks, but start using them with Java 8 language features. That said, there's also plenty of new types coming in Java 8. The previously mentioned collection stream API, which is a great feature, really interesting feature, not the focus of today though, because it's quite independent from Spring. It works great with Spring, but it doesn't require special support from Spring. It just works when you use it within your component implementations. Anyway, for the Stream API, there have been quite a few additional common types being introduced to the Java 8 libraries. In the java.util.function package, you'll find predicate, supplier, function itself. There are quite a few nice, typical, common callback interfaces introduced in Java 8, of course. So I would not expect many frameworks and libraries to start relying on them right now. However, for collection streams, they can immediately be used. If you'd like to do collection filtering, collection mappings of any kind, you'll find APIs in the JDK itself which make immediate use of those new Java util function types. Anyway, so it's all convention-based, one method callback interfaces basically, or more specifically, it's actually interfaces with one method to be implemented. If you have heard of default methods in Java 8 already, you might get a hint of what I mean here. So if there are default methods on interfaces, a new Java 8 feature with a methods basically with a default implementation supplied in the interface itself, that doesn't count. It can still work with Lambdas as long as only one method remains to be implemented. So it doesn't have to be strictly a one method interface. It only has to be an interface with one method left to be implemented. All right, so much for the kind of background here. Very concretely, in Spring, you'll find common interfaces that immediately fit with that convention. Take JdbcTemplate. It's row mapper, result set extract, row callback handler, connection callback, prepared statement setter. All of those callback interfaces that have been established with JdbcTemplate for like 10 years. All of those can immediately be used with Lambda expressions. So it's actually a quite interesting situation if you think about it. You have interfaces and API styles established 10 years ago, and now comes a Java 8, a new generation of Java in the form of Java 8 with new language features, which can immediately be used with those 10-year-old interfaces because they share a design convention. It's actually rare to find in this industry that those things work out like that. We have them, of course, not just in JdbcTemplate. We have them in JMS-template, transaction template, this typical template plus callback style that you can find in many Spring packages. They are all an immediate candidate for Java 8 Lambdas. So that's, from the Spring API design perspective, of course, a great fit. There haven't been many places where we had to fine-tune things for Java 8 in terms of Lambdas. Things just naturally work with Lambdas. So what does this look like in practice? Take just the simplest possible use of JdbcTemplates. Any kind of code that coding context that you're into here, any kind of method, maybe it's even the main method, whatever. You create a JdbcTemplate instance, passing a data source as usual, and then it starts becoming interesting when you look at the query method here, at the actual JdbcTemplate method call. The query method here takes 3 parameters: a SQL string, a prepared statement setter, and a row mapper. 3 arguments. So let's revisit the previous slide for a moment. Prepared statement setter has a set values method, passing in a prepared statement supposed to set parameters on it, basically. Row mapper has a 1-line callback method, results at row number passed in, supposed to return an object per row that is then being accumulated into a list and returned to the actual JdbcTemplate caller. The code that we're seeing here after the SQL statement now exactly matches those interfaces. The first line, the PS line, is a prepared statement set implementation in Lambda style. It basically refers to the parameter PS, which is the parameter coming into the set values method here, and says, with this prepared statement, what I'm doing is I'm calling set string on it. I only have one thing to do here, one statement to do here, so I'll do it with expression style. There are no code blocks here in this version of the example. So with a single simple expression here, we defined a callback implementation of the prepared statement set interface, but that's not what we see here. We see a version of the code that is really condensed and reduced to the very essence. We don't see a new prepared statement setter with a set values method declaration, then a code block, and then comes the set string call. All that we see is a reference to the incoming parameter, basically the incoming method parameter, the variable PS, and the actual method body. It couldn't be much more reduced, could it? In the next line, what we're seeing here is a Lambda that compiles against a row mapper. Row mapper, just for a quick glance here, row mapper has an object map row results at row number method. So results that comes in, current row number, we return an object for it, as previously discussed. So we have rs and row num coming in, results set and the int row num, and we have an expression that says, like, we are calling the result set, calling get string, get int, 2 parameters. We pass them into the constructor of a person object, and that person object is what we're returning. This is the shortest possible version. Notice there's no return keyword. So in this expression style, it's actually reduced again to the very essence. Even the return is implicit, because it's clear that the target row mapper interface has an object return type. So it's clear that this new person here is going to be returned from there. The compiler can infer this from taking the provided Lambda expression here and kind of matching it against the target method signature where it's being applied to. So this is the shortest possible version, but it's actually a pretty good reference example because, for a start, of course, the expression version is the most concise, no code blocks. and it's using 2 lambdas. A key point here is also lambda expressions are most compelling if you can apply more than one at the same time. They really show their power if several of them sit next to each other or are being combined with each other. With a single parameter here, you could imagine, well, do a callback implementation, anonymous inner class style. That's all right. But think about 2 callbacks here. If you implemented the example on this slide with anonymous inner classes, it wouldn't really fit on that slide. There would be the anonymous inner prepared statement setter class, the anonymous inner row mapper class. The more callbacks you have, the more compelling lambdas become. So this is the shortest version here. Take a look at this variation. If you found the first version a little bit alien in terms of syntax, have a look at this one. Maybe this one is closer to your expectations in terms of what Java code is supposed to look like. This is actually the very same code. It just uses a different flavor of lambdas. It uses code blocks. So here you can actually see that the lambda is expressed through a regular Java code block. Each of them, so PS points at a code block and RS row num also points at a code block. The code block needs to follow regular Java rules. So within that code block, you'll find semicolons, you'll find return statements, you'll find, of course, the code block brackets. This is a regular Java code block, needs to follow regular Java coding rules. It can, of course, contain several statements. So in case you want to apply several parameters against the prepared statement, easily possible here. In case you want to pre-calculate maybe something before you create the person object down there, you can easily do that within that code block style. That's basically the 2 flavors of lambda expressions. Let's compare them once more. This is basically the inline expression variant here. And this is the code block variant of lambdas. What you've been seeing here is an almost complete definition of lambda expressions. They are syntactically no more complex than what you've been seeing here. There are just very few additional tweaks. We can even make it complete by mentioning that the PS or RS variable names down there, they can be qualified with a type. So you can say like prepared statement PS, result set RS, int row num. You can add a declaration of the types. You don't have to. That's another variation of this. But that's really about it. Practically speaking, that's lambda expressions for you. From my perspective, that's a great situation to be in. They are really a very straightforward feature, following very few reasonably simple rules. Once you actually, once you warmed up to the syntax, and once you kind of learned those rather straightforward rules, lambda expressions are really easy to apply. In other words, this is not a new Java language feature like generics, which kind of makes an entire industry choke on the complexity of the underlying model for almost 10 years. This is in a completely different league. It's a very simple, straightforward feature where it's actually hard to identify potential for side effects. You can play a few tricks, with with overloaded methods, with arbitrary variations of parameters. There are some cases where the compiler cannot make a unique match for a given lambda. But in any real-life scenario, take the Spring APIs for a start, JdbcTemplate and co. In any such real-life framework and library scenario, lambdas just work. They're really a great fit. To the degree that we can do a judgment here at this very point of time. From the Spring Framework team's perspective, we've been working with Java 8 for almost a year now. So we have a bit of history with this already. And we can actually say that ever since like October or so, this has been a completely smooth development experience with IntelliJ IDEA's tooling support, which was there last year already. This worked very smoothly from rather early on. As of today, of course, we already have JDK 8 in generally available form. So we have Eclipse tooling coming up any day now in its distribution version. So the entire industry is moving on to be Java 8 compatible now. Everything that it takes to use this kind of style in your code base basically is appearing as we are speaking here. A few additional weeks and everything will be there that you could possibly ask for even, except maybe for your deployment environments. But at least the framework and library space is catching up, and the tooling space is catching up very quickly here. So a few additional notes on that towards the very end here. Let's move on to method references. Method references are a kind of a variation of a Lambda, or the other way around. Lambdas are a variation of method references, you could say. I'll add to that in a minute. So what we're seeing here is a very similar example, like a JdbcTemplate, this time used within a method, doing a query call, passing in a SQL statement, passing in a Lambda expression for the prepared statement set, as you can see here, PS set string still there. However, the row mapper is not a Lambda here. The row mapper is expressed through the rather strange looking this : map person reference. That's a method reference. So as of Java 8 with this double colon syntax here, you can refer to a method in your source code. That's actually a type safe reference to that method. So it's not a reflection-based name where you kind of tell a framework that the method to call is named map person. It's an actual compiler method reference. A compiler understands and efficiently applies that reference. So which method does it point to? The map person method can be seen below. It's meant to be on the same class here. Could be anywhere really, but with a this : we refer to a method on the same instance. So the map person method, in terms of its method signature, is kind of compatible with a row mapper. Remember the row mapper? Results are coming in, row num coming in, and an object being returned. This method basically follows the same convention. The compiler actually enforces this. The use of the this : map person reference up there against the Spring JdbcTemplate API that takes a row mapper makes the compiler introspect the row mapper interface. Then it looks at that method signature, and then it tries to basically map them onto each other. It tries to turn this method into an implementation of the row mapper interface. So conceptually speaking, like with Lambdas, you could imagine that there's an anonymous inner class that calls that method. And that anonymous inner class implements row mapper and is being passed on to the JdbcTemplate. That's not what's happening in practice, though. So that's just a kind of mental model, like with Lambdas themselves. Even in particular with the second example from before, it almost looks like anonymous inner classes. So it really helps as a mental model. Think about those as just shortcutted anonymous inner classes. But that's not what they are at runtime. At runtime, the compiler creates really efficient synthetic methods on the same class for each of those lambdas and injects basically a dynamic invocation of that method into the bytecode. It's really, really efficient. It's more efficient than anonymous inner classes are. Not significantly more efficient, but slightly more efficient. The same happens, or something very similar happens with this method reference here. So the compiler basically adapts it to a row mapper implementation that has a straight pointer, invocation pointer down to that map person method. There's no dynamic proxy involved, no reflection involved here. In that sense, it's really significantly more efficient than all the string-based kind of reflection-oriented solutions that may have been out there before. One thing to note here, the mapperson method has a throws SQL exception declaration. Why is that? Well, it follows a standard Java rules, of course, and the getString and getInt methods on results set called in there, they throw SQL exception. So the method also has to declare SQL exception before being turned into a row map implementation by the compiler. That wasn't necessary with the Lambda examples. No throws declarations here. They are inferred, basically. If exceptions are being thrown, they are passed through the target interface properly, but you don't have to declare them anywhere here. You do have to declare them with the target of method references, if there are any such exceptions to declare. All right, that's basically method references. Syntactically, there's actually a lot of nice tricks you can do with this sort of stuff. And there are several examples out there already what you can do with method references, where you can adapt existing signatures to like predicates or to transformer interfaces, signatures that weren't really made to be adapted to those interfaces, but in terms of their declaration, they are compatible with the target interface. It's a subtlety here. If you look at the map person method, nowhere does it say that this thing is implementing the row mapper interface. It basically follows the row mapper interface by kind of convention, incoming parameters, return type, and so forth. The method name is arbitrary, some details are arbitrary. It's almost a kind of duck typing. As long as this method is kind of assignable to the target interface, as long as that's the case, the compiler will actually accept it without a formal implements declaration of any kind. That allows you to design quite a few nice things. Independent pieces of code that can be adapted to target interfaces without any explicit declaration. So this kind of feature, method references, give it a year or two, and we'll see plenty of nice examples of what we can creatively do with this feature in our code bases. What we're seeing here is the most straightforward use of method references. In this case, again, with the Spring Jdbc template. All right. Let's move on to a few further Java 8 features that are actually quicker to explain. There's JSR-310, the Date and Time API in the java.time package. Well known to be led by the same spec lead that also leads the JobcTemplate project. So naturally, it shares some similarities with the JobcTemplate project, but it's not a straightforward adoption of JobcTemplate. It's actually quite different in the details. There's some common terminology, but even the terminology is not entirely common with JobcTemplate, and quite a few commonly named value types. But if you're an experienced JobcTemplate user, keep basically a fresh perspective on the java.time package. You're going to find a lot of things that are familiar, but the deeper you dive, in particular towards the programmatic use perspective, the more differences you'll find. From the perspective of this example here, it's rather straightforward though. This is basically an entity or in a domain model, it would be maybe a kind of value object. Maybe it's an actual domain object. Doesn't really matter. It has two fields that we can see here. Two fields that hold date and time information. In an old school world, you would have declared them as a java.util date. Birth date is a date. Last contact would also be a date. And from the perspective of the type declaration, it would be unclear what you actually mean to store in that date, because a java.util date can be almost anything. Can be a day only. It can be a date plus time. It can be a time within a day. It can be a timestamp in milliseconds. It can be many things. The type itself is not very expressive. So for a start, the most important characteristic of the java.time package, like with JobcTemplate, is the availability of expressive and specific value types. If it's just the date, declared as a local date. If it's a date plus time, declared as a local date time. If it's a date and time within a very specific zone only, declared as a zoned date time. If it's a kind of timestamp, declared as an instant. There's basically an appropriate value type for many kinds of date and time representations. If you start using them in a Spring-based world, like in value types or domain objects that are being managed by Spring, maybe in combination with the Spring data binding, then you can find something like here. The use of the java.time package in combination with Spring formatting annotations. The formatting annotations, of course, have been available for for a few years already in Spring, and they are being supported with java.util Date and Calendar. In particular, they are also supported with JDbcTime types. As of Spring Framework 4, we're also supporting them with the JSR-310 Date and Time types in JDK 8 itself. There are a few subtle nice improvements here. The @date_time format on the last contact is pretty straightforward. That's basically what you can do and could do and can do with JDbcTime as well. You assign a specific parsing pattern through an annotation. Every time the framework binds a string to that field needs to convert it, or every time that field is being rendered out to some kind of textual representation, then basically Spring's formatting framework kicks in, uses that rule by default, that pattern by default. However, with the birth date example above, it's actually commented out. The formatting annotation is commented out. Why is that? It's because we can infer that information from the actual type. If it was a java.util date, you would have to add the date-time format annotation. But through declaring it as a local date, the framework basically knows, okay, that's supposed to be a date representation, so we're using the ISO date representation convention by default. If it's a local time, it uses ISO time by default. Local date time, it uses ISO date time. So it can actually make some educated guessing, some reasonable defaulting based on the value types, based on the actual field types, which basically allows you to drop some of the additional annotations. You remember generics and the generics-based injection matching, where you can drop qualifying annotations? The type itself is so expressive. So there is, on a similar note here, you can use JSR-310 types, which are also very expressive, and the framework can do many reasonably defaulted things with it, just based on the type. That's JSR-310. Two further notes on Java 8. Repeatable annotations. Repeatable annotations in Java 8 are basically doing something that's rather obvious, should have been possible before. Basically, the above example here, with two @scheduled annotations next to each other against the same method, on the same message here, that only works in Java 8. You couldn't do that before. You could only have one declaration of any given annotation type on the same field or method or constructor, etc. As of Java 8, you can do what you see above here. However, it requires a special declaration of those annotations. So what we did in Spring 4 to enable this is that our @scheduled annotation, a good old Spring 3 annotation, is now specifically declared to be repeatable. The Java 8 compiler detects that and automatically allows you to use it, as you can see in the example above here. So that only works with Java 8 against Spring 4. The example below is basically the next best approximation. That works against Java 6 and 7 as well. Kind of a container schedules annotation with a nested array of @scheduled annotations. The syntax above is definitely nicer. Basically, the syntax above is about as expressive and concise as it can be. The syntax below obviously has some noise with the container annotation around. So that's definitely an improvement. And there are a few annotations in Spring that are declared as repeatable now. @scheduled as the best example here, I find. Last but not least, parameter name discovery. We have a tradition of making use of parameter names in the programming model. And as of Java 8, parameter name discovery for method and constructor parameters becomes first class. But let me add some context. Method and constructor parameters in traditional Java don't have a name. They have an index and a type. The name only sits in the source code, but it's not retained in the bytecode. So it's not actually introspectable at runtime, traditionally. The only way out was debug symbols. You could compile your code, your classes, with -debug, which creates a debug symbol section in the class file. And frameworks can then, if they're willing to do so, read that debug symbol section and infer parameter names from it. We have been doing that for quite a while. So that's basically what it took to make it work on our side. as of Java 8, we have a first-class feature now where there's a first-class compiler flag called -parameters that creates a specific section for parameter names in the bytecode in the class file and allows us to introspect the parameter names using standard reflection. Literally with the get parameter, get name on reflection types in the Java API. That's of course great. It basically allows us to translate the requirement that the programming model may come with in some cases onto the Java 8 runtime in the first-class way. So what we do now is basically we try Java 8 reflection if we're on Java 8. If the parameter names are not available there because you haven't compiled with -parameters, then we fall back to our good old debug symbol parsing using ASM. Either way, that's basically a kind of technical requirement. Why do we actually do this? That's the example below. And you may be aware of this already, but this handler method, this MVC handler method down there, look at its path variable parameter. It's declared at path variable long ID. At path variable doesn't explicitly say what the name of the path variable is. It could say so. You could specify it as an annotation attribute, but it doesn't here. In the request mapping path above, it says like books path variable is named ID up there. It's a single path variable, so it's maybe doesn't immediately jump at us. But imagine that there are two path variables, each with an individual name. How do you identify which path variable you're referring to? And what we do here is we take the declared name of the parameter. So this long ID part is actually significant. We take the ID part as a parameter name and match it against the variable names in the URI template above. And of course, to make that work without repeating yourself, without having to redeclare the path variable name through an annotation attribute as a string. So to be as expressive as this here, you can just rely on the functionality above. That's why we have parameter name discovery with a new first-class mode on Java 8. Right. So that's parameter name discovery for you. And that's basically it from a Java 8 language perspective. We have no immediate plans to add any of this to the Spring Framework 3 generation. So Spring Framework 3 is really, in that sense, a child of its time. It can be deployed onto JDK 8 runtimes, but it does not support the Java 8 language level. This is really exclusive to Spring 4. That's what Spring Framework 4 has been designed for. And if you have any intentions to use Java 8 in practice here, then definitely upgrade to Spring Framework 4. That's only part of the story, because even if you're not on Java 8, and even if Java 8 is still a little bit far out on the horizon, nevertheless, we recommend an early upgrade to Spring Framework 4, because Spring Framework 4 is JDK 6 and 7 compliant, compatible at runtime. It has a lot of stuff to offer for JDK 6 and 7, and you're preparing yourself for some selective adoption of Java 8 features through being on the Spring Framework 4 generation. So the moment you have a Spring Framework 4-based application, and you can actually run it on a JDK 8 installation, you can start using some Java 8 language features. You don't have to, but you're basically all set. Spring Framework 4.0 is already generally available for a few months now. It was released in GA form as of December, so a few months ahead of JDK 8's general availability date. And we're already approaching the 4.03 release on our side. So tomorrow you'll find in all likeliness the Spring Framework 4.03 release out there. So it has already had quite a bit of production use. Even if, of course, with Java 8 the production use is only really starting now, we had quite a few early adopters starting strategic development projects on Java 8 before. Because if you know that you're not going into production before 2015, then Java 8 is basically almost a no-brainer to use, as long as you know that you can install it in 2015. So the Spring Framework 4 mission is basically about two things: the best possible development experience on Java 8, of course, next to the best possible runtime experience on Java 8. But at the same time, it's also about trying to prepare yourself for Java 8. The best possible approximation of those things on JDK 6 and 7 is an important part of the picture here. Many of those things work in some form on JDK 6 and 7, using JDbcTemplate, using net schedules, container annotation, using debug symbol parsing for parameter names. So you can do many of those things in some form on JDK 6 and 7. You know that there will be more first-class ways of using those things on JDK 8. Migrating a Spring Framework 4-based application onto Java 8 as it comes to your production environments will be very, very straightforward. That's part of our mission here. All right. That's actually approaching the end of the presentation here. Just a quick outlook, since I was mentioning that we are already GA for a while with Spring Framework 4.0. The team is actually starting work, or has already started work on Spring Framework 4.1. So just as an indication of what we're working towards, there's quite a bit of stuff coming your way with a delivery schedule in September. So Spring Framework 4.1 will have a rather short iteration. It's planned to go generally available in early September, along with the Spring 1 conference. The focus topics can be seen here. If you want to see more details, they can be found on Jira. There's plenty of planning there already. So it's about, for example, revisited caching supports. We have a tradition of adopting specs early. JCache 1.0 final has been out there for a while in almost final state. It's going final any day now, and we're going to adopt it very quickly, even in terms of its caching annotations. We have had support actually for JCache-based backends before, but not for its caching annotations yet. And it's an opportunity for us to revisit our entire caching arrangements. We're also going to revisit our JMS arrangements with the previously mentioned Spring messaging module in mind, analogously designed messaging endpoints, just like you can do for Stomp or what you can do in Spring integration. Basically a simple, straightforward model to do the same kind of thing for JMS. And comprehensive web resource handling is a large area. It's about resource pipelining. It's about fine-tuned cache control at the HTTP level. There are many connected pieces there for basically enabling modern-day web architectures in their most efficient form. Right, and there's quite a bit of further stuff planned. You can find it on Jira. That's really all I meant to indicate for the moment. So thanks for your attention. Thanks for staying on the line for this entire tour here. I hope there's been something in there for everyone. If you have a chance to give Java 8 a try, by all means, consider your options. It may be easier to start using it than you think. Many of the pieces are there. Everything you may actually need at this point may already be there. So definitely check your options there and start warming up to it. This is something we'll all be working with for so many years. All right, and from the Spring Framework 4 perspective, of course, if you're on Java 8, please use Spring Framework 4. It's been designed for that. If you're not on Java 8 yet, please upgrade to Spring Framework 4. Consider Spring Framework 4 as your programming model. Of course, for the very features as they are right there right now for JDK 6 and 7, but as mentioned, also as a preparation for moving on to Java 8 with your application, hopefully soon enough. All right, so much for this presentation. Let's move on to the Q&A section.
Excellent. Juergen, can you hear me?
Yes, I can. So,
excellent, wonderful.
Just looking at the some of the questions.
I've got a couple teed up for you. One question comes from Sunil N, and he said his concern is using generics is that it could heavily degrade the application performance. I was wondering if you could speak to that for a moment.
Well, it's a fair point. Generics, of course, come with some impact on kind of the runtime algorithm if it tries to analyze generic type structures. But in practice, it's on our side, at least from the Spring perspective, it's not known as an actual problem, primarily because once a match or a non-match has been made on Spring side, in all likelihood it's going to be cached. So we are rather aggressive in caching the targets behind injection points. Once we know it's one specific bean and we actually know its ID, we kind of hold on that ID. We're not looking at the type structure again, unless the cache is being cleared for any reason. So we're trying to make it as efficient as possible. From my perspective, my advice would be, don't let performance be too big of a concern here. Use the most natural representation, the most natural type structure that represents what you're trying to express, and kind of rely on the framework in this case to efficiently make the match here. And only kind of as a secondary consideration, you may sometimes opt for simpler type structures. With generics, the main reason to keep your type structures somewhat straightforward is your own sanity. I have seen generic type examples that are really mind-boggling. You'll basically spend half an hour trying to understand the type structure, a few types with plenty of type variables in there. By all means, please keep your generic type arrangement, your type variable arrangement, somewhat straightforward. You're going to have to look at it. Someone else is going to have to look at it in a year's time or 2 years' time. That's actually the most important part. Make sure that you can actually understand the type structure and read the type structure when you have to revisit it. The framework has to do its job at runtime, right? Yeah, it's much more important that the source code remains readable.
Thanks, Juergen. Okay, two more questions. So we're gonna try and keep it short today because I know we ran a little bit over time. Balakrishnan asks, is there any way can we synchronize on multiple listenable future? Something like Guava's futures.allasList and futures.add callback.
That's a good point. It's actually referring to a kind of side note on the slides in Async REST template, and I suppose in its use of listenable futures. It's also a Spring Framework 4 feature. There is not yet a first-class way to sync up on several listenable futures. It would be easy enough to introduce it, though. So if you'd like to see this for Spring's listenable future type specifically, please create an enhancement request on Jira. Sounds like a great idea. There's one note I'd like to add here. Compared to Guava or that kind of library, we're not trying to provide maybe as comprehensive a library as they are doing. For us, types such as listenable future are more important as return types or parameters in our API signatures. That's the main reason why we have them. And we're trying to use common types wherever we can, but sometimes we have to create our own, since for simple use of those return types, we don't want to drag in an extra dependency such as Guava. So that's just a little bit of an extra note. We may not be able to go as far and as fine-grained as Guava does, but if there are some simple enough measures that we can apply, some simple enough utilities that we can add, and they're going to ease your job, we're definitely going to do that.
Okay. Let's see. I think last question before we wrap it up here, and I think this is a good one to end on. Question is from Daniel Ling. He says, will Spring Boot become the recommended way of packaging Spring Framework applications?
It's a good question. I suppose it's a kind of obvious question as Boot goes GA here. Personally, I tend to believe in a very complex and individual situation and on everybody's end here, right? So everybody's requirements differ. There are so many existing experiences that we have with how Spring is used in very diverse target environments. So I personally don't see Boot as a kind of immediate match for like all of those, right? There are many scenarios where you're probably better off with the more traditionally handcrafted, very explicit configuration. Depending on how many people actually have to deal with that configuration, how self-documenting the configuration needs to be. It's also often, do the developers and the architects prefer a very explicit style, maybe just as a kind of additional structural information to hang on to. So there would be many reasons why you choose to opt differently. That said, for many kinds of apps, Spring Boot is a great way to get started, and Spring Boot is also a great way to deploy this thing. We've been seeing, the microservices trend, embedded containers, etc. The moment that you free yourself from, say, the rather tight rules of a managed operations environment, that moment Spring Boot really enters the picture very quickly. So I see basically those two things as somewhat balanced out. I think the more strictly operations managed with environment with pre-deployed infrastructure that Spring has to adapt to will remain as a very common scenario. At the same time, I see Boot and the kind of applications that Boot is made for, I see that segment growing very quickly. So that's the best answer I can give at this point. We'll all see how it turns out. And as Boot goes GA, in just half a year's time, we may already have learned quite a bit about how the industry ramps up here.
Yeah, I completely agree, Juergen. It's hard to say how quickly PaaS and cloud type deployment environments are gonna take root versus the more traditional. So yeah, no, that's great. I think that's all the questions we have for today. I just want to thank everyone for staying on for so long, and it seems like I think we've managed to exhaust all the Spring team in the background has managed to exhaust all the questions in the queue. So just want to let you know that we will be posting the recording to spring.io/video and also a post in the spring.io/blog sometime within the next 2 weeks. If you'd like to get notified about the recording being available, I just recommend that you subscribe to the Atom feed on spring.io/blog, and you will get an immediate notification of whenever we place the webinar replay. Alternatively, you could just subscribe to the YouTube channel if you're just curious about video replays. But if you subscribe to the blog Atom feed, you'll also get lots of great content, including, for example, the fantastic blog entry that Juergen has just written up on Java 8 and enterprise projects, and has a lot of pragmatic insights about how you may be able to use Java 8 quicker than you think, even in the traditional, more explicit configuration type of operations-driven environments. Let's see. So I think last thing to just mention is that we have not yet enabled direct HTTP downloads for Spring binaries from the spring.io website at the moment. We're really trying to encourage people to use Maven and Gradle. If you are desperately in need of HTTP downloads for some reason, you're welcome to visit our Artifactory server at repo.spring.io, and you can have a look at the repository FAQ as well. I'll just place the URL for that actually in the chat, in the Q&A chat window somewhere. Bear with me for a second. Let me pop that in at the end here. There we go. If anyone's looking for the repository FAQ. Other than that, just want to say thanks, and definitely thank you very much, Juergen, for an amazing session, a very informative session.
You're welcome.
And yeah, definitely. Look forward to Spring Framework 4.1 GA and Spring 1 conference in early September. So thank you very much, and I think I'm going to close it out. We'll see you on the next event.